10. Industrial Hygiene Deck 10. Outline of presentation. Hazard identification by industry classification. Hazard evaluation through WEM, instrumentation. Hazard control. What is industrial hygiene? The science and art devoted to recognition, evaluation, and control of environmental factors and stresses arising in or from the workplace, which may cause sickness, impaired health and well-being, or significant discomfort among workers or among citizens of the community. ACU. Prevention of work-related diseases and death in the workplace. Evaluation, WEM, laboratory analysis, comparison with standards, recognition, ocular inspection, process, raw materials, SDS, control, engineering, administrative, PPEs, rightward arrow health hazards rightward arrow safe and healthy working environment. ASCII. Alt. Hazard identification. Chemical hazards. Particulates. Dust. Silica dust. Asbestos. Heavy metals, fumes. Copper. Iron. Manganese. Mercury. Zinc. Organic solvents. Isopropyl alcohol. Methylene chloride. Petroleum ether. Toluene. Xylene. Gases. Carbon monoxide. Oxygen. Ammonia. Hydrogen sulfide. Inorganic chemicals, mist. Phenol. Formaldehyde. Sulfuric acid. GHCS 9 pictograms, format acceptable. TLVs of common organic solvents. ASCII. Alt. TLV of acids. ASCII. Alt. Physical hazards. Noise, vibration, illumination, temperature, pressure, radiation regulated by PNRI or medical devices radiation, FDA under DO. ASCII. Alt. Biological hazards. Substances that pose a threat to the health of living organisms, primarily that of humans. 1. Microbiological. Bacteria, viruses, molds, fungi and protozoa. 2. Macrobiological. Insects, parasites, plants, and animals. Ergonomics hazards. Workplace ergonomics. The science of fitting workplace conditions and job demands to the capabilities of the working population. Fit the task to the person. Indoor air quality. Indoor air quality environment services sector. Example. Business process outsourcing, BPO. Offices. Logistics, warehouses. Schools. Banks. What is indoor air quality? Is a term which refers to the air quality within and around buildings and structures, especially as it relates to the health and comfort of building occupants. Chemical substances in low concentration, CO, VOC, formaldehyde, dust, etc., effects of temperature and humidity, irritating, foul, or stale air, biologic agents such as virus, molds, occupants carbon dioxide rightward arrow sources of indoor air pollutants in buildings * thousands of chemical substances in low concentrations. ASCII. Alt. Hazard evaluation. Rule 1070, OSH Standards, Dole Occupational Health and Environment Control. Establishes the threshold limit values for toxic and carcinogenic substances and physical agents, which may be present in the atmosphere in the work environment. Airborne contaminants. Table B, TLV for airborne contaminants. Table 8A, mineral dust. Table 8D, human carcinogens. Physical agents noise, illumination. General ventilation, air supply, air movement. Work environment measurement. Sample work environments and their hazards. Manufacturing. Painting, exposure to solvents/paints, ergonomics, inadequate illumination, wood, iron and steel, heat stress, exposure to heavy metal fumes. ASCII. Alt. Construction. Solar load, heat stress, dust, cement. ASCII. Alt. Thermal conditions, temperature and humidity. Recommended optimum temperature ranges from 20 degrees Celsius 24 degrees Celsius for indoor office setting. Doctors and indoor air professionals recommend a relative air humidity level of 40 to 60% for human occupancy, proposed. Average humidity levels outdoors, moderate climate. 70% to 75% relative humidity. Alt. Sampling. Types, area and personal. Personal sampling. Worn by individual in breathing zone. Follows all activities. Sampler sees the same air as is inhaled. Give the best estimate of workers' exposure. Area sampling. Fixed location sampling. Good for source evaluation, oriented towards machines, equipment, or areas rather than persons. May not represent workers' exposure. Determine hazardousness of area. Alt. Alt. Collection methods for chemical sampling. Liquid absorption sampling method. Solid absorption sampling method. Direct sampling method. Filtration sampling method. Collection method, liquid absorption method for acids and inorganic chemicals. A sample pump is used to bubble air through the impinger which contains a liquid medium that has been specified in the method. The liquid will physically dissolve or chemically react with the chemical of interest. Solid absorption sampling method for organic vapors. Many sampling methods require the use of sorbent tubes for sampling gases and vapors. A sorbent tube is a small glass tube normally filled with 2 layers of a solid sorbent material. Sample will then be analyzed through chromatography. Alt. Direct sampling method. Detector tube pumps, multi-gas monitor. ASCII. Alt. Sensor height locations for typical gases. Sensor mounting height and location. Lighter than air %Lel %/% volume. On or near the ceiling. Breathing zone ppm, 4 to 6 feet above floor. Lighter than air, breathing zone, heavier than air. Alt. Near the floor %Lel %% volume, 6 inches above floor. Gases. Hydrogen, H2. Methane, CH4. Ammonia, NH3, ppm. Carbon dioxide, CO2, ppm. Carbon monoxide, CO. Chlorine, Cl2. Formaldehyde, CH2O. Hydrogen sulfide, H2S, Oxygen, O2, ozone, 0.3. Nitric oxide, NO. Nitrogen dioxide, NO2. Phosphine, pH3. Sulfur dioxide, SO2. Carbon dioxide, CO2, % volume. Filtration method for dust and metal fumes. To sample for heavy metal fumes, a filter loaded into a filter cassette will be used. The filter diameter, type, and pore size will vary depending on the chemical being sampled and will be specified in the sampling method. ASCII. Alt. Alt. Height of measuring point for dust measurement. 50 to 150 centimeters above the floor. To measure the density of particulates in a space where workers breathe. To prevent particulates accumulated on the floor from being taken into a collecting device. Alt. Air sampling. Calibration. Calibration of air sampling pumps is an integral part of the accurate measurement of airflow rate and volume. Exposing an instrument to a known concentration of a gas, and checking the accuracy of its response. Calibration means to set and verify the flow rate of the pump. Calibration should be done before and after every sample that you take. Flow rates are measured in ml/min or L/min. Internal monitoring 2 criteria. WEM trained personnel, so. Calibrated equipment must have calibration certificate, source of issue. Calibrator, for flow rate. Flow meter, a device used to measure the volume of air. ASCII. Alt. 2 general types of air sampling methods. Active sampling is the collection of airborne contaminants by means of an air sampling pump and a collection media. Area/environmental sampling. ASCII. Alt. Personal sampling. Alt. Passive sampling is the collection of airborne contaminants at a rate controlled by a physical process such as diffusion through a static air layer or permeation through a membrane without the active movement of air through an air sampling pump. Are badges or a range of small samplers that collect air contaminants without the use of a pump. Individual chemicals simply diffuse from the atmosphere into the sampler at a fixed rate. Alt. Seg and sample size, whom to sample. Similar exposure group, SEG. A group of persons who experience exposures similar enough that assessing the exposures of any member of the group is predictive of exposures of all members of the group. SEG sample size. Determine the sample size N from a statistical table to obtain a high probability of sampling a high-risk employee, e.g. sample size for top 20% and confidence level of 95% given below. ASCII. Alt. Selection of worker, whom to sample. Selection of highest risk worker, also called worst case sampling. Nearest to source. Duration and frequency of exposure. Nature of work or work practice. Availability of control measures. Sample transport/shipment. In general, it is always a good idea to send samples to the analytical laboratory quickly. If shipping liquid, they must be shipped in liquid-tight containers. Be sure to include enough absorbent material to absorb all the liquid in the shipment if sample leakage occurs. Use suitable packing materials to prevent breakage of samples. Some samples will need to be stored and shipped at low temperature. Use pre-frozen gel blocks whenever possible. Store samples in refrigerator/freezer until just before packing. Make sure to use a chain of custody form to ensure that each person who handles the samples is accounted for, and that samples are identifiable after receipt by the laboratory. Documentation. Documentation is the key. Always document everything. Have a checklist so as not to forget even small details. ASCII. Alt. Noise levels. Factors in determining safe levels of noise. The level/volume of noise. The duration of exposure to noise. Where and when to measure the noise level. A position near the worker's ear, 1.2 to 1.5 meter above the ground/floor. Fixed operational position of worker. Under ordinary noise conditions in the work area. In a time zone deemed to have the highest noise level. Sound level meter. Unit of measurement, dBA. Alt. Permissible noise exposure, PINE, level. ASCII. Alt. Ceiling value, no exposure in excess 115 dB, A, is allowed. Exposures to impulsive or impact noise shall not exceed 140 dB peak sound pressure level, see weighted. Standards/guidelines. Threshold limit values for impulse or impact noise, sound level, dB, permitted no of impulses or impacts/day. ASCII. Alt. Asterisk decibels, peak sound, pressure level, Re 20 UPA. Basic principle of noise control. Controlling or attenuating noise at its source. Controlling or attenuating noise along its path from source to listener. Controlling or attenuating noise at the receiver, listener. Engineering control. Modular acoustic screens, provision of cover to engine box, vibration isolators, sound absorbing materials, dampening materials, raffle hanging arrangement. ASCII. Alt. Administrative controls. These controls are established by establishing policies and procedures to lower the risks of exposure. Arranging work schedules and the related duration of exposure. Selecting machine operating times. Purchase agreements. Standard operating practices. Training/education of workers and supervisors. Noise measurement/evaluation. Housekeeping. Using job rotation schedules that limit the amount of time a worker is exposed to noise. Transferring workers in a workplace where there is no noise exposure. Limit the amount of time a worker spends at a noise source. Scheduling maintenance or operate noisy machines in times where few workers are present, evening shift. Warning alarms/signages. Safety and health policies/hearing conservation program. Personal hearing protection devices. Earplugs, pre-molded, VSTR, 2-flange, 3-flange, customs molded, formable, foam, fiberglass, silicone, semi-insert, 2-position plastic band, 3-position metal bone, ear muffs, attached to hard hat. ASCII. Alt. Heat stress. Measurement method. Heat exposures should be assessed by the wet bulb globe thermometer, WBGT, method. Heat measurements should be made at least hourly, during the hottest portion of each work shift or during the hottest months of the year. Measurement requirements. Environment heat measurement should be made at or close as feasible to the worker area where the worker is exposed and represent the environmental heat conditions at the worker's position. Screening criteria for heat stress exposure. Allocation of work in a cycle of work and recovery, temperatures for light, moderate, heavy acclimatized. ASCII. Alt. These TLVs are based on the assumption that nearly all acclimatized, fully clothed workers with adequate water and salt intake should be able to function effectively under the given working conditions without exceeding a deep body temperature of 38 degrees Celsius 100.4 degrees Fahrenheit. They are also based on the assumption that the WBGT of the resting place is the same or very close to that of the workplace. Where the WBGT of the work area is different from that of the rest area, a time-weighted average should be used. Heat stress control measures. Labor Advisory No. 3S. 2016, Safety and Health Measures to Prevent and Control Heat Stress at the Workplace. Heat Stress Management Program. Acclimatization Program is a gradual physiological adaptation that improves an individual's ability to tolerate heat stress. The process whereby the body adapts to the temperature variations of the area. Such a program basically involves exposing employees to work in a hot environment for progressively longer periods. Illumination. Measurement of illumination. Lux meter. Units of measurement, lux. Alt. Recommended illumination levels. Type of work/operation performed. Minimum lighting level. Discrimination of detail is not essential. Passageway, corridor, warehouse. 50 lux. Slight discrimination of detail. Engine, boiler, locker, washrooms, etc. 100 lux. Moderate discrimination of detail. 200 lux. Close discrimination of detail. 300 lux. Discrimination of fine detail. 500-1000 lux. Discrimination of extremely fine detail. 1000 to 2000 lux. For offices with visual display terminal, VDT. General illumination to be kept relatively low. Illumination of 200 lux is recommended at VDT workstation. Illumination of 300 lux is found most comfortable for entry of figures. Glare. Glare is what happens when a bright light source or reflection interferes with how you are seeing an object. Especially bright points or areas within the field of vision in the range from straight ahead to 45 degrees above the horizontal. Often a reason for low quality and productivity, reduction in the ability to see, discomfort, annoyance and eye fatigue. Reflected glare is caused by light reflected from polished, shiny or glossy surfaces. Glass on picture frames, or windows at night. Monitors/screens. Direct glare is caused by very bright light from poorly positioned light fixtures. Sunlight. ASCII. Alt. Direct glare. ASCII. Alt. Reflected or indirect glare. ASCII. Alt. How to reduce or avoid glare. Use blinds, curtains, shades, etc. Rearrange workstations. No naked light bulbs or tubes should be in view of the worker. Use of louver on the lighting fixtures. Avoid shadows. Shadows make it difficult to work because eyes will adjust to surrounding light. Ensure regular maintenance. Lack of regular maintenance can result in the loss of 10 to 20% of light. The accumulation of dirt on luminaires results in a loss in light output. Cleaning of light bulbs, fixtures, windows, skylights, inside and outside, walls, ceilings and other interior surfaces. Vibration. Biodynamic coordinate system. X-axis, back to chest/front to back. Y-axis, left to right/side to side. Z-axis, head to toe/up and down. The highest and major vibration level usually occurs on the vertical axis or up and down motion of the floor, which is the contributing factor when it comes to whole body vibration measurement. ASCII. Alt. X-axis, through the hand. Y-axis, across the hand. Z-axis, along the length of the hand arm. ASCII. Alt. Whole body vibration, WBV. While the TLV and AL curves may be used as a guide in the control of WBV exposure, they should not be regarded as defining a distinct boundary between safe and dangerous level. TLV and AL weighted acceleration levels. ASCII. Alt. Hand and arm vibration. ACA TLVS refers to the daily vibration exposure 8, hour energy equivalent total value A, 8, of 5 meters per square second. That represents conditions under which it is believed that most workers may be exposed repeatedly without progressing beyond stage 1 of the Stockholm Workshop Classification System for Vibration-Induced White Finger, WWF, also known as Raynaud's phenomenon of occupational origin. Regulations, guidelines, and references. International Standards for Human Vibration. ISO 5349 Measurement and Evaluation of Human Exposure to Hand, Transmitted Vibration. ISO 2631 Evaluation of Human Exposure to Whole Body Vibration. ISO 8041 Human Response to Vibration, Measuring Instrumentation. ISO 8662 Human Held Portable Power Tools, Measurement of Vibrations at the Handle. ISO 6954, Guidelines for the Measurement, Reporting and Evaluation to which passengers and crew are exposed in railway vehicles. ISO 10326 Laboratory Method for Evaluating Vehicle Seat Vibration. Practical advice for measurement and evaluation of human vibration can be found in VDI 2057. The subject of human vibration has gained particular importance in Europe since the Directive 2002/44/EC came into effect. It specifies the duties of employers with regards to workers' protection. Hand-arm vibration, L140. Work environment control. Comprises of measures which aim at the elimination or reduction of exposure of workers to potential work environment hazards. 1. Engineering control. 2. Administrative control. 3. Use of personal protective equipment. Environmental control measure. Ventilation evaluation. Equipment, anemometer. Unit of measurement, M/S. Rule 1076, General ventilation. OSHS air supply/air movement. 1. Clean fresh air shall be supplied to enclosed workplaces at an average rate of not less than 20 to 40 cubic meters an hour per worker. 2. Air changes per hour. 4. For sedentary workers. 8. For active workers. 3. Air movement. Rainy season equals 0.25 m/sec. Summer season equals 0.75 m/sec. ACH equals velocity, m/sec, times area outlet, m2, times number of outlet times 3600 divided by room volume, m3. ASCII. Alt. 4 to 8 ACH, volume of air supplied with respect to room volume or activity of the worker. 6 to 12 ACH, COVID prevention. Exercise, compute ACH. Given, air velocity equals 129.5 fpm, area of outlet equals 0.3 m x 0.9 m. Number of outlets equals 5. Volume of room, L equals 10 m. W equals 8 m. H equals 4 m. Acceptable comfort air motion at the worker. Industrial ventilation, a manual of recommended practices, published by the American Conference of Governmental Industrial Hygienists. Continuous exposure. Air velocity, m/s. Air-conditioned work areas. 0.25 to 0.375. General ventilation for workstations. Spot cooling, sitting. 0.375 to 0.625. Standing. 0.50 to 1.0. Intermittent exposure, spot cooling. Light heat loads and activity. 5 to 10. Moderate loads and activity. 10 to 15. High loads and activity. 15 to 20. Capture velocity measurement procedure. Canopy/updraft hood, capture velocity, V position of probe. ASCII. Alt. Recommended capture velocity. Updraft canopy hood, capture velocity, m/s 0.25. Updraft canopy hood is not recommended if material is toxic and workers must bend over source. Airflow. ASCII. Alt. Direction of airflow, locate the hood so the contaminant is removed away from the breathing zone of the worker. Rules on cost-effective ventilation. Use natural airflow. ASCII. Alt. Use push-pull ventilation. ASCII. Alt. Capture velocity measurement procedure. Position of probe remote canopy hood, normal temperature, at edge of the contaminated area, most remote from hood. Canopy hood, hot process, along outer rim of canopy. ASCII. Alt. Summary. There is no generic IH sampling protocol that fits all workplaces and hazards. Correct recognition of hazards. Logical sampling strategies. Proper evaluation, lab. Results and computation. Correct interpretation, OSH standards. Appropriate control measures.